Hopefully you've had a chance to try this problem out on your own. I'm going to walk through the solution now and please follow along. Um, so here we have, it's another equilibrium problem and we're given a bit of information. We are told the equilibrium constant, great. We've got a chemical reaction, fantastic, we're going to need that. And we're given equilibrium concentrations. Now, looking at this, I immediately noticed that I have a product that I already have a concentration for. It's not necessarily zero. And so immediately I think, oh gosh, I should check the quotient, the reaction quotient, and make sure I know which direction this reaction is going to proceed. Is it going to form more products or more reactants to hit equilibrium? And I'm also going to need to, so I'm going to develop my equilibrium expression anyway. So I'm just going to go ahead and do that right here. So my equilibrium expression is that Kc value, which is equal to 0.64, which is going to be equal to the concentration of our carbon dioxide plus or times the concentration of our hydrogen, all divided by the concentration of carbon monoxide and the concentration of water. Now, all of my coefficients are 1, and so I'm not going to have any exponents other than 1 in this expression. Also, I'm going to note something. Our water is in the gas phase. It's in the same phase as everything else. So we are going to include water because it's in the same phase as everything else. And so it's not just the solvent, it's just a reactant product. And as we change its concentration, it'll affect equilibrium. All right, so here is my KC. I'm going to do a quick check and make sure I know which direction this is going. So if I do that, I'm going to find that Q is going to equal, I'm going to plug in my initial concentrations. So it's going to be for my carbon dioxide, 1.0 molar. For my hydrogen, it's going to be 0 molar. For my reactants, it's 1.0 molar on my carbon monoxide and my 2.0 molar on my water. And that's going to give me a value of 0. So 0 is less than 0.64. Therefore, my reaction is going to proceed, or it's going to go towards the product side for reaching equilibrium. All right, so got that out of the way. Now I'm going to start setting up my ice table. So I'm going to rewrite my equation so I've got everything together. I'm going to start with my I, C, and E. And my equation is carbon monoxide plus H2O. And I'm being super lazy and I'm leaving out my phases. And I apologize. You can be lazy like me, or you can put them in. All right. And I know it's going to go in general towards products because my Q is less than my K. So I'm going to go ahead and populate the information that I know here. So I know my initial concentrations. I know that I have 1 molar of my carbon monoxide. So I'm going to put that in 1.0 molar. I know my water is 2.0 molar. I know my carbon dioxide is 1.0 molar too. And my H2, my hydrogen, is 0. Now I'm going to put in my change. All my coefficients are 1, so I'm just going to be using minus x or plus x. I know it's going to go ahead and form more products to reach equilibrium, so I'll be decreasing the concentration of my reactants. So my change will be minus x for both the carbon monoxide and the water. Now, looking at the products, they're both going to increase to reach equilibrium. And so I'm going to add x to both sides, both my carbon dioxide and my hydrogen. Now I'm going to rewrite my equilibrium concentrations in terms of x. So it's going to be 1.0 minus x, 2.0 minus x, 1.0 plus x, and 0 plus x. Or we'll just call that, how about we just call that x? All right. Now I'm going to take these values here and I'm going to plug them into my K expression. So I've got 0.64 is equal to my products over my reactant. So I'm going to do my 1.0 plus x times x, all divided by 1.0 minus x, and times 2.0 minus x. Okay, now that I've plugged that in, it's time to solve for x. I'm going to update some instructions here. Now I'm going to work on solving x. I'm going to first start by expanding out, multiplying out my everything in the parentheses. So remember that's going to be first, then outer, then inner, and then last. So remember, we're going to use FOIL. So I'm going to do that for both sets, and I'm going to jump ahead to that piece right now. So this is going to, and then I'm going to rearrange this equation quite a bit. So what I'm going to do is work to get these x's all to the point where I have expression for a quadratic equation. Sorry. And so I'm going to have this set up as 0 equals ax squared plus bx plus c. And so I'm going to save some space and some time and just skip to that step. If you have any questions about it, though, my solutions will have the detailed steps of it. So this is going to become 0 is equal to 0.36x squared plus 2.92x minus 1.29. And so I have right here A, B, and C. And so I'm going to plug that into my quadratic equation. And so this is going to look like x is going to be equal to negative b. So I'll put this up in the side right here. X will be equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So I'm going to plug in my values for that. So I'm going to get something that looks like negative 2.92 plus or minus the square root of 2.92 squared minus 4 times 0.36 times, oh, and I barely have room, negative 1.29. That's all square root. And that is divided by 2a. So it's going to be 2 times 0.36. Whew, that's a lot. So I'm going to plug this in once into my calculator using a plus sign after the negative 2.93, and the second time using a negative sign. So I'm going to get two solutions out. I'm going to get x is equal to negative 8.5, or it is equal to 0.42. Guess what? One of these makes sense and the other doesn't. I can't have a negative change when I'm talking about actual molecules, right? Like we can't have them disappear into nothingness and then like have more than we have leave or gain, right? We still have the conservation of mass that we have to follow at all times. So that makes it the 0.42. That's our reasonable answer. So I'm going to go ahead and plug this value right here into my expression for my equilibrium concentrations. And so my equilibrium concentrations for each of these, my 1.0 is going to be 1.0 minus 0.42. Then I'll have 2.0 minus 0.42. I'll have 1.0 plus 0.42, and I'll have 0.42. So that concentration of carbon monoxide is going to be equal to 0.58 molar. My concentration of water is going to be equal to 1.58 molar. And those are my reactants. Now, my products at equilibrium are going to be carbon dioxide with a concentration of 1.42 molar, and my hydrogen gas with a concentration of 0.42 molar. And those are going to be my equilibrium, concentrations for this reaction. Now, if you are having any trouble with the algebra of this, of solving for x, please let me know. We can always work through that together in more detail.